if you have anything missing. Let her know if you have it done so you could take care of it. What kind of questions did you come across on page 151, 152?
Oh, number 2.
Number 2?
Yeah.
You got it. Number 2, I have a squared minus 16 is equal to 0. Okay? So, few things just to remember. This problem is called the difference of two squares. All right? Oh my gosh, squares. SQU. All right. So remember the difference of two squares equation is this. If you have two perfect squares, you're going to have x and y offset by a positive and a negative. Okay? This is a squared minus 16. So this is a perfect square, and this is a perfect square, and this is a subtraction. So this is the difference of two squares. So I'm going to get a plus 4 and a minus 4 to factor. Remember we did that at some point? I hope. All right. So that means that my answers are a plus 4 equals 0. So a equals negative 4. And a minus 4 is equal to 0. So a equals positive 4. There's my two answers. Okay? Of course, I showed more work. You might be able to get this done quicker. What other questions could I help you with? Yeah. 5? Number 5. All right, number 5 looks like this. 2a squared minus a is equal to 3. Yeah, yep. All right, friends, is this one set up equal to 0? It's not equal to 0, so I'm going to move the 3 over by subtracting it. So I'm going to get 2a squared minus a minus 3 equals 0. Now how this is set up, this is going to allow us to factor. So I'm going to multiply negative 3 times 2, and I'm going to get a negative 6. And if I multiply two numbers together to get a negative number, what do you know about the two numbers? One is what, and one is what? Good, positive and negative. All right, now I want to figure out which factors of 6 would add up to negative 1. So I have negative 3a and positive 2a. If I multiply negative 3 and positive 2 together, I get negative 6. If I combine negative 3a and positive 2a together, I get negative 1. So this right here is going to replace this value here. So I get minus 3a plus 2a minus 3. Take a look what you have in common. I have an a, so I get 2a minus 3. Plus sign comes down. I can't factor anything out, so I'm going to put a 1. 2a minus 3. So that means that a plus 1 and 2a minus 3 is the factored version. We're going to set each of them equal to 0. So I'm going to a plus 1 equals 0, so a equals negative 1. And then 2a minus 3 equals 0, so add 3. Divide by 2. There's my two answers. $15, was that the one that was asked for as well? Somebody? 15? All right. Ready to move on?
Yeah.
Thank you. 15 was asked about. So I have x to the third minus 21x squared equals 100x. All right. Is it equal to 0 as it sits? No. So let's move the 100x over. X to the third, x to the second, and x are not like terms because they have different exponents. So we get to that. Good so far? All right. So in this class right now, if I have x to the third, what can you pretty much guarantee one of the answers has to be? I can guarantee one of my answers is going to be 0. Okay? So because I could factor an x out of each of these, I get that. I could take care of this right there. So let's just ignore the rest, and I'm just going to say x squared minus 21x minus 100. So we want to factor it. So I get negative 100. I know I have plus and minus. The factors of 100 that add up to negative 21. I think I could do 4 and 25. 4 times 25 is 100. And so I'm going to go negative 25x and positive 4x. If I add those together, that gives me my negative 21x. So I'm going to have x squared plus 4x minus 25x minus 100. Factor an x out. Negative number comes out. I can factor negative 25 out. So I'm going to get x plus 4 equals 0. So x equals negative 4. And x minus 25 equals 0. So x equals 25. So my answers are 0, negative 4, and 25. All right. This is actually a good one that let me take a pause at. I want you to realize what you're actually solving when you're doing this. Okay? No, we're not going to use this. I just want to use this as a visual. Okay? If I were to graph this problem, I'm going to show you on Desmos how it works. So I got y equals x raised to the third minus 21x squared minus 100x. And I take it back to home. All right. So friends, I can't show you everything yet, but I can show you this one. Was one of our answers on that problem negative 4? And was one of the answers 0? What was one of the other answers? How much? 25? There we go. All right, ready? See the x values of those points? That's what the answer is. Okay? So this graph, basically, it's a third-degree polynomial. So it comes up, goes down, comes back up. Okay, you can explore more of this when you get to Algebra 2. But this is basically what this graph looks like with our vertices here, here, and here. Yeah, this point's labeled. This is called the local maximum. Take me for senior year business calc, you'll learn about that. Okay, so that's what this is doing. Is there any other questions I could work out for you from the homework? We good? Everyone happy? All right, my friends, will you turn to page 153, please? 153. All right. So on page 153, I want to give a couple examples of difference of two squares. These are all samples of difference of two squares factored out. Okay? I am not worried about you knowing this because we can factor like normal. You can just put those examples. Another real key example would be like 25x squared minus 36. That would be 5x plus 6 and 5x minus 6. And how I know that is I'm dealing with perfect squares. We've been dealing with perfect squares a lot. Perfect squares are when I have an exponent that is an even number. That means it's a perfect square. So like some of the things we might have seen, we could have like x to the 50th power minus 9. This would become x to the 25th plus 3, and x to the 25th minus 3. It's a very simple pattern as long as you can recognize perfect squares. Okay. We ready?
No.
Okay. I can wait.
So, sir, real quick question. So, like, both sides are equal to each other, right?
Yeah. That's why there's an equal sign.
Okay. So, like, if we were to like factor out the first one, it would equal x squared to the minus 1, right?
Say what?
Because I think some students are a little confused about how the x squared minus 1 is equivalent to like the 2 parentheses on the other side, if that makes sense. Like how they're equal to each other.
So let's say I had x squared plus 4 and x squared minus 4. So if I FOIL this together, I get x to the 4th plus 4x squared minus 4x squared minus 16, which gives me x to the 4th minus 16. So this is a perfect square. This is a perfect square. This is a subtraction sign. So that's the difference of two squares. So basically, I was showing how this factors. Okay? You're looking for perfect squares. Friends, when we ask for perfect squares and we say, hey, what's a perfect square of 64? What's the square root of 64? And you give me 2, you're not even close. You're looking for a perfect square means I took a number and I took the exact same number, not changing it a bit, and I multiplied it to get there. So that's why we've been listing our perfect squares to get there, etc. So 25. Okay? That's etc. So on page 154, take a look at this. So answer this question, my friends. Is x squared a perfect square? X squared is a perfect square because the second power is an even number. That means a perfect square. Is 36 a perfect square? Okay. So what am I going to put? It's the same pattern every time. Some of you are trying to think too hard about this. It is the simplest pattern. You ready? Eyes up at the board. XX. Y'all still with me? Because we already said they were both perfect squares, right? Plus, minus. Agree? Square root of 36. Done. Then all you do is you set it equal to 0 because you're going to say, okay, x plus 6 equals 0. Subtract 6. X minus 6 equals 0. There's my answers. Such an important concept. Well, we came back to you. I'm glad you recognized it as we've done it before. All right. I'm not the biggest fan of number 2, but we're still going to work it. Is it equal to 0? No, so I have to move something. I have to move something. Okay? Come on. Let's do that here. God, come on. Killing me. All right. Do you agree? All right. Is 25 a perfect square? Yeah. Is x squared a perfect square? Is 49 a perfect square? Is y squared a perfect square? Is this separated by a subtraction sign? Is this the difference of two squares? Yeah. So ready? Square root of 25 is what? 5. Square root of x is what? X squared is what? Square root of x squared is what? Good so far? I'm going to have a positive sign. I'm going to have a negative sign. Square root of 49 is what? Square root of y squared is? All right. Now, we want to solve, and basically we're solving for x, meaning I want to get x by itself. So this one's a little goofy. But it works. So I'm going to set this up, and I'm going to set this up. So on this one, I'm going to subtract 7y from both sides. 5x equals negative 7y. Divide by 5, divide by 5. So x equals negative 7y over 5. Same with this one. Add 7y, add 7y. 5x equals 7y. Divide by 5, divide by 5. So this one's a little goofier because you're getting x is equal to not a number, you're getting x is equal to a number, like a fraction with a letter in it. But that's how that one solves. It's kind of sort of goofy.
Can I ask why we would subtract that y first and not x?
Because we want to solve for x.
How do you know? Oh, anytime, clarify. For these specific problems coming up, we're always solving for x.
We probably should have the directions here, solve for x.
Because I was like, sir, if I have questions. Okay. Thanks.
Yep. Friends, may I move forward? You ready? Everyone ready? We're all set? All right. So this one is not the difference of two squares. Agree? I could factor it. I get positive 49. In order to multiply two numbers together to get a positive number, they both need to be positive or they both have to be negative. So are they both positive or are they both negative? They're both negative, and this is why right there. And let me stop right there. Do you understand why a negative, it's negative, negative, and not positive, positive? So if I add two positives together, guess what? I get to a positive number. If I add two negatives together, I get more negative. All right. So I want to know the factors of 49. If they're both negative, that when I add them together or I combine them together, I get negative 14. 7 and 7. They're both negative. Okay? So that works right here. All right, ready? X squared minus 7x plus 49. I have an x in common. Middle sign comes down. I can factor a negative 7 out, so the sign's going to change. So I wind up getting x minus 7 and x minus 7. It's equal to 0. So this means that x minus 7 equals 0. So x equals 7. Okay? I could solve the other one and also get the answer being x equals 7. This is something called a double root. Okay? It's not broken. Let me show you what this problem looks like if it was graphed. I'm going to jump back on Desmos and show you. Can I move off the screen for a moment? Okay, it's a double root, meaning I get the same answer twice. So if I graphed y equals x squared minus 14x plus 49, I get a parabola. And notice my answer's right there. It crosses the x-axis. It's a root. I only had one answer. So this particular problem, when you have a double root, that means that the vertex from graphing falls on the x-axis. It bounces off the x-axis. It's called the double root. You do indeed have two answers. It's just two of them happened at the same time that are the exact same answer. Okay? All right. So without even graphing the second one, I'm going to graph it first and show you what it looks like. Again, you don't need to know how to graph these on Desmos, my friends. I'm showing this to you so as a visual representation, plus 150. Okay? So my answer, I'm going to have two answers. I'm going to wind up getting x plus 5 and x plus 5 eventually on this problem. Okay? I have a double root that takes place on this problem. And I know if you're looking at the original equation going, yeah, but it's 6x squared plus 60x plus 150. How do I get us having an answer of just -5? Well, let me show you. Okay? Friends, can I divide everything here by 6, including the other side? Those cancel, so I get x squared plus 10x plus 25 equals 0. Okay? Factor it. Positive 25. In order to get a positive number, both signs have to be positive, positive, or negative, negative. In this case, they're both going to be positive, positive, because everything's positive. So what factors of 25 multiply together, or would add together to give me 10? What? Yeah, so 5x plus 5x. If I add 5x and 5x, I get 10x. Factor out. Middle sign comes down. Factor of 5 out. Bring it up here. So I get x plus 5 and x plus 5. So do you see why there's a double root on this problem? They get the exact same thing. So this x equals 5 is why this happened here. It gave us a bounce. All right, my friends, how about page 155, 156? Odds are 1 through 23 odd. Deal? Maria, odds? What's that one? Odds? OD. 1357. Let's see if I can. Did I say all in the video or odds? All or odds?
All right, guys, you have the rest of the time to get this done, so I will start working on it.